Genetics, Lesson 2.6, Incomplete Dominance and Codominance. So last time we talked about how to do Punnett squares and the dihybrids and complete dominance questions, so really simple ones. But now we'll talk about incomplete dominance and codominance. I mentioned them a little bit before, but we'll go into a bit more detail of them today. Okay, so before we start, let's do a little bit of review of Punnett square terminology and just how to draw one. So starting off, we have homozygous dominant. Homozygous, remember, means same. So of course we make the letters both big P, big P. And we know it's uppercase P because it's homozygous dominant. And remember, we always make the dominant trait uppercase P to represent that it's bigger and more dominant. Next, we have homozygous recessive, and remember that homozygous again means same, and this time it's recessive, so that's why we have lowercase p, so sort of making it small, because it's recessive to the dominant trait. Then we have heterozygous. Heterozygous means, sort of the way I like to remember it, is like different, so we have one of each. We have a big P and a little p. The reason that it's big P, little p is because the dominant trait is still telling the little trait what to do, but you have to say that this person who is heterozygous could possibly carry the recessive trait. So I'll just say that big P equals the color purple and the little p equals the color white. Now, the homozygous dominant one will be obviously purple, because both of the letters are big P, big P. The homozygous recessive one are both little p's, so it's going to be white. And the heterozygous one is big P, little p. But remember that the dominant one is telling the little one what to do. And because our dominant color is purple, the heterozygous one will be purple. Now let's just do a quick review on how to draw a Punnett square. So if you remember, we do a cross. So let's say I'm just going to cross two heterozyguses together. So we have a big P and a little p times a big P and a little p. And we just draw this sort of chart thing. And remember, we draw them on the side like this. It doesn't matter where you, which one goes on which side, as long as you put them on each side. And now we just cross them together, so these cross like this and so on. So then we just write big P, big P, little p, and then little p, and that's it. And then obviously you would write the genotypic and the phenotypic ratios. Now let's talk about the difference between codominance and incomplete dominance. So codominance is sort of what I like to call a combination. So I remember like combination, like that. So there's a pink flower and a white flower mixed together, and it gives you a pink and white flower. So it kind of mushes together to give you a combination of the two. So you see questions like this, like feathers and birds. That could be a bird could be a black bird and a white bird mixed together, and then their child will be black and white feathered mixed, stuff like that. So you just have to remember that it's sort of a combination of the two. So like striped, checkered, polka dot, splotches of the different colors like that. Then we have incomplete dominance, which is, again, I have that red flower and the white flower, but this time they mix together like paint palette, like the way I like to imagine it, and they give you pink. So this one is sort of fully mixing them together. So like you could also have, let's say, white and brown. You would mix those together. That would sort of give you a beige color. So the way I like to remember this one is like mixing something on a paint palette, and what would that give me? Okay, now let's do some practice questions of both of them. So we'll start off with the codominance one. The gene for black feathers, big B, may be codominant to the gene for white feathers, big W. It's important to remember that for codominance, we actually don't use lowercase letters. We only use uppercase letters. The heterozygous condition produces a bird with checkered black and white plumage. So we know that this is codominance because we have, like the picture shows, a white bird, crossed with a black bird, and that's going to give us a black and white bird. So it's just like that pink and white flower that we saw. Determine the genotypic and phenotypic ratios for a checkered mixed with a checkered chicken. So first we should determine that this white chicken is going to be WW because it tells us that white is representative to white. Then we have a black chicken, which is obviously going to be black, black. But what will be this checkered chicken? Well, since we don't use lowercase letters, it's not going to be any type of big B, little b, or big W, little w. It is actually going to be just a pure combination of the two. Big B, big W, like that. So the question tells us to cross two checkered chickens together. So we are going to cross a big W, big B by a big B, big W. And we are just going to draw our Punnett square now. So we have big B, big B, big B, big W, big B, big W, and big W, big W. Now it asks us to write our genotypic and phenotypic ratios. So remember, for genotypic, we write the number ratio. So we have, let's count. We have 1 that is big B, so we'll write that. We have 2 that are big B, big W, and we have 1 that is big W, big W. So we'll just actually write big B above this one, big B, big W above that one, and W above that one. Now we have the phenotypic ratio, and this one is where we actually use like the words to describe. So it's the same thing, except we write it in words. So we have 1 that is black, because the big B represents black, so we just write black below it in small letters. We actually have 2, just like in the one above, that are checkered, so I'm going to write checkered under that one. And then our last one, just like up here, the WW one, is white. And that is how you do a codominance question. Now let's take a look on how we do a codominance question. So for this one, we do that same similar setup of using uppercase and lowercase. So in goats, the alleles for coat color display incomplete dominance. So it already tells us that. When the dominant brown-coated animal is crossed with a recessive white one, the animal produced is beige. Find the offspring when a beige goat is mated with a white goat and state the phenotypic ratio. So let's start off. It tells us that the dominant one is going to be the brown. So we can write big B is equal to brown. It also tells us the recessive one is going to be white. So we can write little b equals white. And then the sort of combination one is going to be big B, little b is equal to beige. Perfect. Now we can do the cross, and it tells us that the cross is going to be between a beige goat and a white goat. So we have our beige goat, which is big B, little b, crossed with a white goat, like that. Now we can draw our Punnett square. So we have big B, little b, big B, little b, little b, little b, little b, little b. And this time it just asks us for our phenotypic ratio. So, and remember, the phenotypic one is when we use sort of words, so like the actual colors to describe. So let's take a look. We have 2 at the top that are match our beige letters, and then we have 2 at the bottom which match our white colors. So we have 2 that are going to be beige and 2 that are going to be white. Now some people like to reduce it down to 1-to-1 just because we reduce ratios, but you don't have to. And that's it for incomplete dominance and codominance.